Hello guys, welcome once more to another video again on our YouTube channel. So in today's video we are going to look at ordinary level mathematics, specifically a topic called indices. So as displayed to you on your screen, please, I recommend that you should like the video, subscribe and share the video to your friends, especially most of you who are writing this year 2025-2026 GCE examination for the ordinary level Cameroon GCE. Okay, so as displayed to you on your screen, you can reach me on WhatsApp via the telephone number displayed to you on your screen, and you can equally reach me on YouTube or on the YouTube platform via Mathematics Dreamland for Africa, the MDLFA. Okay, so without wasting much of our time, let's get started. Okay, so we are going to look at indices. Okay, so indices, also known as index form, is a simple way of writing very large or very small numbers to economize space and time. Like for example, you can be writing 2 to the power 5 as 2 times 2 times 2 times 2 times 2 times. That is all about time consuming and space, of which you can just condense it to 2 to the power 5. Okay, yeah, so that is it. Okay, for example, m power n is in index form. The number n is called the index or the exponent or the power, and m is the base. Okay, so m power n means multiply m by itself n times. Okay, so for example, I have p power 5 being equal to p times p times p times p times p. Okay, according to the definition that it is time consuming. You see that for me to write p times p times p times p is actually time consuming. Okay, so, yeah, so that is indices. Okay, so let's look at the laws on indices. Okay, the first law is talking about the multiplication law. So what is this law all about in indices? Okay, for any real number a, m and n, we have that a power m multiplied by a power n is simply equal to a power m plus n. Okay, means whenever the bases are the same, just simply add the powers. Okay, so that is it. Okay, so we are going to look at some example. Okay, I have that evaluate 5 power 4 times 5 power 6. So yeah, since the bases are actually the same, I will just take 5 then add the powers. Okay, so we are going to have that 5 power 4 times 5 power 6 being equal to 5 power 4 plus 6, and that will actually give us 10. Okay, 5 power 10. You can actually punch the values on your calculator for you to have the answer. But I'm actually emphasizing on the law according to the multiplication law. Okay, yeah, so that is it. All right, let's look at the division law. Okay, the division law states that a power m divided by a power n is still equals to a power m divided by a power n, which is equal to a power m minus n. Okay, so when the two bases are the same, you simply minus the power for the division law. Why for the multiplication law, when the bases are the same, you simply add the powers. Okay, yeah, so that is it. So let's look at some of the examples, and it is very important to know that a, m and n should be set of real numbers here. Okay, yeah, so that is it. All right, so let's look at some example on it. All right, evaluate x power 4 times x power 3 times x. This times x is like times x power 1. Yeah, if I just write x, it simply means x power 1. Yeah, even 5, if I just write 5 simply means 5 power 1. Or any number n simply means the number is raised to the power 1. Okay, since anything raised to the power is actually the same thing, so that is it. So let's look at this example. Okay, the example is 4 power x multiplied by x power cube multiplied by x power 1 divided by x power 5 times x power 2. Okay, so let's look at the solution. So x power 4 multiplied by x power 3 multiplied by x power 1 divided by x power 5 times x power 2. Okay, we have that x power 4 plus 3 plus 1 divided by x power 5 plus 2. Why? Because the bases are actually the same. Okay, yeah, the bases are the same. Even in the denominator, the bases are also the same. Okay, yeah, so if I take 4 plus 3 plus 1, I'll have 8, and divided by 5 plus 2 is actually 7. So I'll have x power 8 divided by x power 7, and by applying the division law, that states that a power m divided by a power n is equal to a power m minus n. So here is the same thing. Since x represents a here, so I'll have x power 8 minus 7. Okay, so this is equal to this, implies that x is equal to 8 minus 7, and if I take x power 8 minus 7, I'll have x power 1, but it's still the same as x. Okay, yeah, so that is it. All right, so let's look at the exponential law. Okay, what does the exponential law state? It states that for any real number, don't forget that this definition here, for any real number a, m, and n. So even though I did not indicate in these other laws like here I indicated here, but just know that a, m, n, and n must be set of real numbers. So the exponential law states that for any real number a raised to the power m multiplied by n, that is bracketing it and multiplying it by n, is simply equal to a power m multiplied by n. That is, if you have a number, say 5 power 2, right, then you bracket it and multiply it by another power outside. So it simply means that just take the inner power, multiply by the outer power. Okay, or you take the outer power, you multiply by the inner power, since multiplication is commutative. Okay, yeah, so that is it. All right, let's look at an example under this. Okay, evaluate 9 power cube multiplied by power 4. Okay, so let's look at it. So solution, we have that 9 power cube multiplied by power 4 is simply equals to 9 raised to the power 3 times 4. You see, so just take this the inner power and multiply by the outer power. Okay, or simply just multiply the two powers. So we are going to have that 9 power 3 times 4, and we know that 9 power 3 times 4 is simply equal to 9 power 12. So it depends on you. You can actually take a calculator and punch the value for you to have the value. Okay, all right, so let's move to the next law, which is the zero index. What does this law state? It states that for any real number a, don't forget, it's always good to define it for any real number, because the definition is actually specify that a, m, and n are real numbers. Okay, so yeah, that is it. So for the zero index, we have that a power 0 is simply equal to 1, and a should be different from 0. Okay, so that is it. All right, so if we look at an example under this, we have that evaluate 5 power 3 divided by 5 power 3. Okay, so we are applying in this case, you notice that we are applying two laws here. We are going to apply two laws here: the division law and the zero index law. Okay, all right, so let's look at the solution. So we have to record that. So this is what I was saying. We are using this division law and the exponents and the zero index law. Okay, so record that 5 power 3 divided by 5 power 3 is simply equals to 5 power 3 divided by 5 power 3. Okay, so and by applying this division law, we know that 5 power 3 divided by 5 power 3 is equal to 5 power 3 minus 3. Okay, and we have that 5 power 3 divided by 5 power 3 being equal to 5 power 0. And what do you notice? You notice that 5 power 0 is the same as 1. Okay, so this is the zero index law, that a power 0 is equal to 1. So it therefore means that if I take 5 power 0, I will have 1. So it implies that 1 is equal to 5 power 0. Now where is this one coming from? It's like saying 5 power 3 divided by 5 power 3. So if this one, we cancel this one. So here one time and here one time. So 1 divided by 1 is 1. That is why we have 1 equal to 5 power 0. Okay. Yeah, so that is it. All right. Okay. Let's continue. Okay, now we are going to look at the negative index, or the law of negative index. Okay, so for the negative index, if you have any real number a raised to the power negative n, it's simply equal to 1 divided by a power n, and a should be different from 0. Okay, yeah, so that is it. All right, let's look at an example. So we have evaluate negative 3 multiplied by power negative 4. Okay, so we have the solution there. So we have negative 3 multiplied by power negative 4, or negative 3 raised to the power negative 4 is simply equal to 1 divided by negative 3 multiplied by power 4. Okay, yeah, so that is it. I notice that it will be equal to 1 divided by negative 3 times negative 3 times negative 3 times negative 3. That is a typo error here. It's a typo error. It was supposed to be times negative 3. I'm very sorry about that. So here it was supposed to be times negative 3. Here it was supposed to be times negative 3. Yeah, it was supposed to be times negative 3 there. Okay, so you notice that this negative will multiply with this negative to form positive, and this other negative will multiply with this other negative to form positive. Okay, so that is it. All right, so if you notice that yes, actually, so that is a typo error. So negative 3 multiplied by power negative 4 is simply equal to this negative was not supposed to be there. So yeah, this negative was supposed to be positive here. Was supposed to be positive, and 3 raised to the power 4 is simply, so it now be negative 3 raised to the power 4, which will be 3 times 3 times 3. Now 3 times 3 is 9. Okay, and the other 3 times 3 is 9, and 9 times 9 is 81. So here was supposed to be 81. So that is a typo error. Here was supposed to be 81. Yeah, it was supposed to be 81. Okay, so I'm so sorry about the typographic error. Okay, let's continue. So let's look at the rational indices. Okay, what is this rational indices all about? Okay, for the rational indices, we consider a real number n being raised to the power 1 divided by n. So it's simply equal to n root of a for a greater than 0, and n should be different from 0, because if I take 1 divided by 0, it will be actually undefined in mathematics. So n should not be 0. Okay, all right, so that is it. So if you look at an example on this, okay, there's this other rational indices law also. Okay, so if you have a raised to the power m divided by n, it is simply equals to the n root of a multiplied by power m. Okay, yeah, so that is it. And notice here again that a should be greater than 0 and n should be different from 0. Okay, yeah, so that is it. Now if you look at some examples on it, we have simplified the following. 27 raised to the power 1 divided by 3, 100 raised to the power 1 and 1.5, and 35 raised to the power negative 3 over 5. Okay, so we have that 27 raised to the power 1/3, and it is simply equal to the cube root of 27. Okay, by applying this law here, we have that a raised to the power 1 divided by n is equal to n, the n root of a. Okay, so it's the same thing here. 27 power 1/3 is simply the cube root of 27. Okay, which is equal to 3. If you take a scientific calculator and you input the cube root of 27, you are actually going to have 3. Okay, that is it. All right. So okay, so the second one we have 100 raised to the power 1.5. Okay, so yeah, this is actually a mixed fraction. Okay, so what I'll do is that I will take 2 times 1, which is 2, then plus 1, which is 3. That is why I have 100 raised to the power 3 over 2. Okay, and this is simply equal to the square root of 100 multiplied by power 3. Okay, yeah, so that is it. All right, then that is it. So now look at something here. What do you notice? Notice that the square root of 100 is actually 10. Okay, therefore this being equal to 10 raised to the power cube. Okay, because the square root of 100 is 10. Don't forget that everything here is raised to the power cube. Okay, so that is why I have 10 raised to the power cube, and which is equal to 1000. Okay, yeah, so that is it. All right, so for the next case we have 35 raised to the power 3 divided by negative 3 divided by 5. Okay, now since there's a negative here, we are going to apply this negative index law. Okay, so we have that 1 divided by 35 raised to the power 3 over 5. Okay, and now we are going to apply this law here, the rational law. No, this one here, we are going to apply this one in the denominator. Okay, so we are going to have 1 divided by, now since 5 is in the denominator, I'm going to take the fifth root of 35, then multiply by what is in the numerator, which is 3. Okay, yeah, so that is it. Now it depends on you if you want to have the values in decimal or whatsoever. So I just decided to keep it here like this. Okay, yeah, so that is it. So you can see the calculator, I punch and have your answers in decimals. Okay, yeah, so that is it. All right, so let's look at the exponential equations. Okay, so so these are just some of some examples under the rational indices. Okay, so now let's look at exponential equations. All right, an equation of the form 3 raised to the power x being equal to 27 is an index or exponential equation in x. This equation can easily be solved if both sides can be expressed in the same basis or in the same base. Okay, so what is this point saying? It means that if I have 3 raised to the power x, I can only solve this equation if I can express this other side in base 3 also, so that I'll take this power and then I equate it to the other power here, that will be here, provided I've put this other side in base 3. Okay, yeah, so that is it. All right, let's look at some of the examples. All right, solve the equation 3 raised to the power x being equal to 27. So actually we are actually solving this equation here. Okay, yeah, so let's look at the solution. Okay, 3 power x being equal to 27, it implies that 3 raised to the power x is equal to 3 raised to the power 3. Why did I choose to raise it to the power 3? Because 3 times 3 times 3 is actually 27. Okay, so you notice that the bases are the same. Okay, so now we can apply the first law of indices, with that when the bases are the same, they actually not actually the law, because here the bases are the same, but the two bases are in the other side of the equality sign. Okay, so what we do here, since the bases are the same, so we can just equate the powers. Okay, since 3, the base here is the same as each other base here, therefore x is equal to 3. Okay, yeah, so x is equal to 3. So we have solved this equation. So that is how we are going to be seeing some equations of this nature, that they will ask you that solve this. Make sure even the value here is big, maybe your own question might come that this value is big, but struggle away for you to know that since as the question has been given in this nature, and you notice that the number here is 3, just know that in this other side too, you have to express the base 2 as 3. Okay, so the base in this other side is supposed to be in 3 also. All right, so it depends on how the equation will come. Here might be 4. Okay, so it means on both sides the bases are supposed to be 4. All right, so that is it. Okay, so let's check example 2. Okay, find x if 4 power x is equal to 1 divided by 4 power cube. Okay, so we are going to apply this law here. Yeah, we are going to apply this law since we have 1 divided by 4 power 3. It means that it is simply equal to 4 power minus 3. Okay, all right, so let's look at it. So that is it. So it implies that 4 power x is equal to 4 power negative 3, and since the bases are the same, we simply equate the powers. Okay, and therefore x is equal to negative 3. So that is just all. So it is not really that difficult. Just know that you have to express the basis. You have to express the basis such that the left hand base should be equal to the right hand base. Okay, so that is it. All right, we have number 3 there. So solve the equation 3 power 2 multiplied by x minus 1 is equal to 8 multiplied by 3 power x minus 2, which is equal to 1. Okay, all right, so this is very important. In fact, most questions in the GCE, this is how they actually set them. Yeah, in the ordinary level, this is how on indices, this is how they actually set the questions. Okay, so let's look at it step by step. Okay, so we have 3 power 2x minus 2. So how did I arrive here? Okay, let's go back here. We have 3 power 2 multiplied by x minus 1. So here I've just expanded the bracket. Okay, so I have 2 multiplied by x, I have 2x, and 2 times negative 1, I have negative 2 here. Okay, now minus. Okay, here we apply the division law here. Okay, the division law of indices, we apply it here. Okay, so that since I have 3 power x minus 2, it simply means that 3 power x divided by 3 power 2. Since according to the division law, I can actually express this as being equal to 3 power x minus 1 minus 2, which is the same as this value here. Okay, so that is it. Okay, now if I express it in this way, I have it that all of this is being equal to 1. Okay, so now what I will do is I will take now I will expand this bracket also. Okay, such that I will take 3 and I multiply it by 2x. So I will have 3 power 2x. Now the minus sign is just like this case here. So it means it will be 3 power 2x divided by 3 power 2. Okay, like this other case here. So at the end of the day, we are going to have that 3 power 2x divided by 3 power 2 minus 8 multiplied by 3 power x divided by 3 power 2, which is equal to 1. Okay, so all this is equal to 1. Okay, now let's focus here. So 3 power 2x divided by 3 power 2. So notice that this 3 power 2 is like saying 3 times 3 here, which is 9. And here is the same thing. So at the end of the day, we are going to have that 3 power 2x divided by 9 is equal minus 8 multiplied by 3 power x divided by 9. Okay, so what are we going to do here? It means we are going to multiply everything here by 9. Okay, it means if I multiply here by 9, the 9 will cancel with this other 9 in the denominator. And also, if I multiply here by 9, the 9 will also cancel with this other 9 in the denominator. And therefore we are going to have that. Okay, yeah, that is it. So we are going to have that. If we multiply all through by 9, we are going to have that 3 power 2x minus 8 multiplied by 3 power x is equal to 9, because I've multiplied everywhere by 9. Okay, yeah, so that is it. Now there is a technique here that is actually disturbing most students, okay, at this point. Okay, look at something here. This is 3 power 2x, right, minus 8 multiplied by 3 power x, okay, which is equal to 9. Now what I will do is that I will send these two, since it is multiplication, right, and multiplication is commutative. Okay, means I would say 3 power x times 2, not 3 power 2x again. Okay, since multiplication is commutative, I will say 3 power x times 2. Okay, and then if I do that, now I will just remove the 2 outside, which is still the same. Okay, which is still the same according to there is a law there that which law is that? That if you have a real number a power n multiplied by power of m is simply equal to a power mn. Okay, so it's the same law here. So it means I will take this x inside, then I take these 2 outside the bracket. Okay, so at the end of the day, I'm going to have that 3. Okay, I've just sent this 9 inside. Okay, means yeah, that is it. So now this 9 is actually in the other side of the equality side. Now if I send it inside, I'm going to have all this minus 9 being equal to 0. Now by just looking at this equation here, it's actually going to be a quadratic. Okay, yeah, so let's just continue. So this is what I was actually saying. You see, now I've just sent this x inside. It's the same thing. This 3 power x all multiplied by power 2, right, is the same thing as this term here. Okay, let's look at why it is the same. Okay, now if I decide to arrive here back, okay, so I will have 3 power x multiplied by power 2. Now I will just multiply this 2 with this x according to that law of indices. Okay, now if I multiply this x with this 2, I'm going to have 2x. That is why I decided to express it in this form. Okay, I notice that what I have is 3 power x all that squared minus 8 power 3x, 3 power x minus 9. Notice something. We have 3 power x here and we have 3 power x here. Now we can assign something to be this 3 power x. Okay, so if I let y to be 3 power x, it implies that I'll have y squared minus 8y minus 9 being equal to 0. Okay, yeah, I notice that since I've let y to be 3 power x, it means anywhere I see 3 power x, I will just put y there. So I've substituted y here. That is why I have y squared minus 8y minus 9 being equal to 0. Now this is a quadratic. You can use a quadratic formula, or you can just factorize. Okay, so if I factorize, my two values are negative 1 and 1, negative 9 and 1. Okay, so if I look for my y, I have that y is equal to 9 or y is equal to negative 1. But notice that y is equal to 3 power x. Yeah, from here, y is equal to 3 power x. It implies that 3 power x is equal to 9. Okay, or 3 power x equal to negative 1. Okay, but if I solve this other 3 power x being equal to 9, I'll have that 3 power x equals to 9 implies 3 power x equal to 3 power 2, but 3 power 2 is equal to 9. Okay, so I've just make these two bases to be the same, and since the bases are the same, I'll just equate the powers. So it implies that x is equal to 2. Okay, now for this other part here, there will be no solution. Okay, there will be no solution here. Okay, so for 3 power x equal to -1, there is no solution in the set of real numbers. Okay, yeah, so that is it. Okay, now we are going to look at the graphs of exponential function and approximate solution. So in these indices, okay, in these exponential equations, not actually all of them can be solved here, because look at like that case that we have 3 power x being equal to 27. So we can actually express 27 as 3 power 3, but in cases where we can have 3 power x being equals to 7, it means there is no way that we can actually express 7. We can actually express the 7 in base 3 there. Okay, so that is why the graphs are imposed. Okay, all right, so okay, observe that the equation 2 power x being equal to 5 cannot be solved directly because we cannot express 5 to base 2. Yeah, so we cannot express 5 to base 2. Okay, now but we can obtain an approximate solution by graphical method or graphical approach. Okay, this involves drawing the graph of y is equals to 2 power x and the line y is equals to 5. Now the solution will be gotten at the point of intersection of these two lines, or the curve and the line. Okay, yeah, so that is it. Okay, now if I choose some values, because in this graph I choose my values should be between -4 and 4.5 here, and then if I choose my value of x, now I substitute it here. So this is a graph. Now for me to obtain the solution of this equation here, this equation, since I cannot express 5 in base 2, therefore means I have to graph it. Now since I've chosen my value of x to be between -4 and 4.5, it means if you graph it, this is how the graph is going to look like. Okay, so this is a line y is equals to 5. This is here, this is a line y is equals to 5. Now you notice that this is a curve. This is a curve y equals to 2 power x. It's an exponential curve. Okay, now the solution will be in the point where this line intersects with the curve. So this is the solution. So it means we are going to extrapolate from here, and then we'll read the solution here in the x-axis. Okay, so that will be the value of x. Okay, yeah, so that is it. Now from the two graph, or from the curve and the line, the point of its intersection is at x equal to 3.2. Yeah, so 2.3, sorry. So when I was graphing it, the graph was actually drawn to scale, and I read out the value to be x being equal to 2.3. Okay, yeah, so that is it. All right, we have to note that from y equal to 2 power x, when x equal to 0, y will be equal to 2 power 0. Okay, and anything raised to the power 0 is actually 1. Hence the graph passes through the point 0, 1. So if you come back in the graph, you see that this is the curve. The curve is an exponential curve. Okay, we notice that it passes through 1. Okay, and it means that when x is 0, y is 1. That is why when x is 0, y is 1. That is why the graph passes through the point 0, 1. Because some of you might be asking why the graph passes through this point. Okay, so you can actually choose your own values at random. You can choose values between even -10 and 10, or -10 to 20. It depends on you. Okay, yeah, so that is it. Okay, so that is it. Okay, also the graph of y is equals to f of x approaches the x-axis but does not cut it. Okay, hence the line y equal to 0, which is the x-axis, is an asymptote to the graph of y is equals to 2 power x. Okay, yeah, so that is it. Okay, so this is the end of the video. So please, I'm going to upload the other videos on logarithms and surds. Okay, so I did just indices here because I never wanted the video to be too lengthy, which might actually increase the cost of megabyte. Okay guys, see you in the next video. Thanks.